Good morning, all of you. I am Prashant Sharma, Assistant Professor from IPS Academy, IS Indore. Today, I will discuss the topic of analysis and design algorithm, Huffman coding. Now, what is the Huffman coding? The Huffman coding is basically used to compressing the data, which is transferred in the network from one end to other end. The main use of the Huffman coding is to reduce the size of your data. Basically, the data containing the characters and each characters having ASCII code. So basically the Huffman coding is a technique for compressing data to reduce the size without losing any of the details. It was first developed by David Huffman and is generally useful to compress the data in which there are frequently occurring characters like this. This is the message which containing 4 characters A, B, C, D. Like this is a very small message. If we are transferring over the network and we use ASCII encoding, we know that ASCII encoding use 8 bit for each characters. So 8 bits each character, and this total number of character is 15. So each character takes 8 bit, then total number of bits transfer on the network is 8 into 15. It means 120 bits are required to send this string. By using Huffman coding, we can compress the string to a smaller size. By using Huffman tree, we firstly create a Huffman tree, which is based on the frequency of character which occurs in this string. And this Huffman code is basically transferred over the network with a tree. The decoding is also use this same tree for the receiver end. So the Huffman coding prevent any ambiguity in the decoding process using the concept of prefix code. So each character contain a prefix code. Now we discuss this above string BCCA, which is given above. How can we convert this string into the Huffman coding? The Huffman coding is done with the following step. Firstly, we calculate the frequency of all the characters in your message. Here, B's occur 1 time, C occurs 6 times, A occurs 5 times, and D occurs 3 times. Firstly, the message which will be given to you, first step to identify, to know what is the character's frequency occur in your message. The first step to calculate the frequency of each character in the string. Now the second step to sort the character in increasing order, because Huffman coding use optimal merge pattern and greedy approach. So first we arrange the characters in increasing order according to your frequency. We use the priority queue to store these frequencies like show in the above message. Now this frequency are sorted in the increasing order. In the next third step, we make each unique character as a leaf node. All the leaf node containing your character which is occur in your message. Like firstly we arrange complete message frequency B, D, A, C in increasing order. B occur 1 times, D occur 3 times, A occur 5 times, and C occur 6 times. Firstly, we select starting minimum values and create it as a leaf node of the tree. And now in the fourth step, we create an empty node asterisk, which is the minimum frequency of the left child and the assigned second minimum frequency to the right child of this asterisk node. Set the values of is the summation of those 2 minimum frequencies. After this, we remove this 2 minimum frequency from the priority queue and add summation of this frequency into the list, which is denote internal node. Internal node denote the summation of the frequencies. After inserting this new frequency, this is the 4. In previous slide, you can see that after B and D frequency added, then new frequency 4 is created, which is called asterisk node. Now in second step, we are rearranging this frequency according to given frequency. Internal node is 4, A occur 5 times and C occur 6 times. After this, again we sort in this increasing order, remove this 2 frequency from the queue and end summation of this 2 least frequency, denote the internal node of your previous figures. Now insert again new node 9, which is the summation of 4 and 5. Then addition of 6 and 9, which is the 6th node is C, and addition of 15. Now it is completely created Huffman tree. Now after creating this Huffman tree, we assign each left edge 0 and right edge to 1. Now how can we calculate each character Huffman code? We traverse from the root node to the leaf node. For example, if we calculate the Huffman code of A, then we start from the root node, which we have frequency 15. Now traverse from the root node 15, we travel up to the node, leaf node A, then we get 1 1 as a Huffman code of character A. Like B Huffman code is from traversing from the root node 1 0 0, then D from 1 0 1, and C is only 0. Now this table are created. A having Huffman code is 1 1, B is 1 0 0, C is 0, and D is 1 0 1. This code is created by this Huffman tree. Now, when we are transferring the above string into the network, we required without Huffman coding 120 bits over the network. Now by Huffman coding, how can we reduce message below the 120 bits? Now here A having 2 bits for transferring. A character occurs 5 times, so its total size is 5 into 2, it means 10 bits. Similarly, B occur in the message 1 times. Now B having the Huffman code 100, it means it having the size of 3 bit. Now C having the Huffman code is 0. Now its size is, because C occur in the in your string is 6 times, and its Huffman code is only 1 bit long. So it occupy total number of bits in the message 6 into 1, it means 6 bit. Now similarly, D occurs in your message 3 times, and its Huffman code is 101 according to tree. Now it occurs in your message 3 times, and its size is 9 bits. So the complete message size is 28 bits, which is reduced, and as compared to 120 bits, it is very much long. Now the characters, how can we send this tree into the network? Tree is transferring into the character A. So character A, B, C, D, 4 characters are basically transferred according to their actual ASCII values. It means 8, A having ASCII value 8. So total number of 4 characters is transferred into the Huffman tree. So total memory required is 8 into 4 equal to 32 bits. So the total and the frequency is 5, 1, 6 and 3 of respective characters are also need to transfer in the information. Let we having information from 1 to 1, 3 means maximum values is 5, and 5 is binary code. Actual binary code is 101, 1 have binary code 001. If we transferred on this tree on the network, so the tree, how much memory occupied by the tree? Let frequency 5 is binary code 101, 1 occupy 001, 6 occupy 110, and 3 occupy 011. So the total number of frequencies transferred according to tree 4 into 3 equal to 12 bits. So the message size which is transferred over the network is 32 bits for ASCII encoding. Now the message size is total 120 bits without encoding, and after encoding the size is reduced to 32 plus 12 plus 28 equal to 72 bits, where 32 bits is required for transferring ASCII characters. It means A have ASCII characters long, actual ASCII code of A is 8 bit long, and we need to transfer total number of 4 characters. It means 8 into 4 equal to 32 bits character, and its corresponding frequencies takes 4 into 3, because here is a number is 1, 6 and 3 and 5, which we have used only 3 bit encoding for representing this number of frequency. So total number of bits are transferring is 12 bits. So the size of message is 32 bits plus 12 bits plus 28 bits is the size of actual message. Now at the receiver end, this tree is used to decode your messages according to this Huffman tree. For example, if the first character is B, which B having the Huffman code 1001. So frequency and the receiver end, it can be checked that how this character are come into your messages. Then traversing from root node to leaf node, when we occur B, then we required 100 Huffman code, then system automatically detect according to algorithm 100 is a B code. Then this decoded your messages according to this Huffman tree. 1001 is decoded, we can traverse from the root node as is a figure given below. Now what is the algorithm of Huffman coding according to first create a priority queue consisting of each unique character. Priority queue is used for always store data in increasing order, so we use priority queue data structure. Then sort them in ascending order according to their frequency. Now for each unique character we are creating each new node, then extract the minimum values from the priority queue and assign it to the left child of new node, and then extract minimum value from the queue, second minimum value from the priority queue, then it create the right child of the new node. The new data values of frequency are calculated by left child frequency values and the right child frequency values. So after inserting this node into the priority queue, again we create new node, then again we create minimum values from the priority queue, two minimum value priority queue, then summation of these two minimum values representing the new node frequencies. This process repeatedly until no characters remains in your algorithm. Now after encoding, after completing this tree, we are use Huffman coding at the sender for sending the message or compress the message, and receiver end, this tree is used to decode your messages. Now what is the time complexity of algorithm? Because we use priority queue, so priority queue takes to get smallest element from the priority queue takes log n time, and because these processes are repeatedly two times, so because we are required to select two minimum value, so it takes 2 into n minus 1 times to get extracting minimum frequency from the priority queue, and the time complexity is log n for extracting minimum value, so it required 2 into n minus 1 into log 2n. So overall time complexity of this algorithm is big O n log n base 2. Thank you.